the soil, you'll have less erosion, isn't it? Similarly, here also. But for this, we need some stable soil aggregation. The soil aggregates which are formed should be stable because you're going to apply a external pressure over the soil. So if the granules formed or the aggregates formed are very soft, then it would be easily broken. Okay, so for this, you need a stable soil aggregation to resist this compaction. Soil requires stable aggregate formation. Okay, and again, when there is more water content in the soil, okay, when you have water in the soil, so water will form a thin film. I'll share my whiteboard. Are you able to see this whiteboard?
Yes, ma'am.
Okay. So in the soil, while you have more water, okay, water in the soil, this water forms a thin layer surrounding every soil particle. Okay, around every soil particle, water will form a layer. So when this is the case, you will not be able to get stable aggregate formation, isn't it? So the interaction between these two particles itself is reduced. Okay, so that is what you learned in fundamentals course also. Have you? Do you remember? Workability in the soil.
Yes, ma'am.
Yes. Okay. So when you have more water, you'll not be, you will not get stable aggregate formation, isn't it? Even while you were doing the field method, you should apply the exact amount of water. Now, exact means at least to some extent water should be added. If you do not add enough water, then again you will not have a ball formation. Similarly, if you add excess water, you will not have a ball formation or any formation you cannot do. So to have stable aggregates, you should require some amount of clay, little amount of salt, not little amount of water, not excess water. Okay, so in this condition, when you have more water in the soil or in the field, this kind of soil will be more susceptible for soil compaction. Okay, the water layer forms a shield over the particles, and this reduces the particle-particle interaction, and thereby it reduces the stability of soil structure. When you do not have stable soil structure or stable aggregates in the soil, then the soil is highly susceptible for soil compaction. Okay, whereas if you have some stable aggregates in the soil will resist the compaction when a heavy pressure is applied over the soil. If you have stable aggregates, then it will resist resist to some extent. Soil compaction can be resisted. Okay, so in the soils where the bulk density is already higher. You all know soil compaction causes increase in the bulk density. Whereas if the soil is already dense, if the bulk density of the soil is already more, then what will happen under that case? The particle-particle interaction will be more, isn't it? All the particles are very close to each other and you have more of particle-particle interaction. So under these conditions, again, the soil will resist compaction. Okay, so whatever whichever factor is able to resist compaction, there you'll have only less soil compaction. Okay, if you have such factors. So now you can see the factors which make the soil more susceptible to compaction. Okay, coming to soil texture. So while you were learning about soil erosion, which kind of soil resists erosion to some extent? Sandy soil or clayey soil? Which soil can resist soil erosion? Kripa Shankar?
Clay
Good.
soil.
Elizabeth? Okay. Everyone good. Srinidhi, Elizabeth, Belsi, all. A clayey soil can resist erosion because of the formation of aggregates. Okay. Similarly, here also that holds good. But the thing is that in a clayey soil, you have more of surface area. Isn't it? The surface area is more for clayey soil. Do you understand? The porosity is more in which kind of soil? Clay soil or sandy soil? The porosity.
Sandy soil.
Sandy soil.
In sandy soil, you have more of macropores. Okay, the macropores are more. But if you consider the total pore space, micropores and macropores taken together, the clayey soil will have more pores because the clayey soil is very small in size, isn't it? It is less than 0.002 mm. The individual particle, the size of individual particles is very, very low compared to a sandy soil. So surrounding every clay particle, each and every clay particle, you will have a surface area. So the total surface area is more for clay soil. Similarly, the porosity is also more for a clay soil. Because if you take some 100 grams of soil, 100 grams of clay soil and 100 grams of sandy soil. Okay, the total porosity will be more in clay soil. Similarly, the surface area also will be more in the clayey soil because the soil is very fine. Okay, do you follow?
Yes, ma'am.
Yes, ma'am.
Okay, so when this is a condition, when you have more of clayey soil, there is every possibility of all the soil particles being surrounded by water. If there is a rainfall or irrigation, or even water will not stand for a longer time in sandy soil, whereas water will stand in the clayey soil for a longer time because of the presence of which pores? Capillary pores. Okay, due to the presence of capillary pores, water will stand in the clay soil for a longer time. So when there is a little excess of water, the water will form a shield over individual clay particles. And of course, the clay particle will form aggregates, but that is not a stable aggregate. Okay, so a clayey soil is more susceptible to compaction. It will easily undergo soil compaction compared to a coarse textured soil. So in a coarse textured soil, you have sandy particles. So the sand, the size of the sand is bigger and it will resist compaction to some extent. Okay, do you all follow? This is just like your tug of war. So which side of that rope is stronger? They'll not fall down easily, isn't it? They'll pull the other side. Similarly, whichever soil particle is stronger will resist compaction, and the other soil which is more susceptible to changes will undergo compaction. Okay. The next factor is soil structure. So, you know, different types of soil structures. What are the different types of soil structures? Yes. You also draw a diagram for that question, isn't it?
Yes, ma'am.
Mm.
Ma'am, angular,
Very good.
granular, like that, ma'am.
Yes. Angular.
Columnar and blocky,
Very good.
block-like structure, ma'am.
Very good. Prismatic, columnar, isn't it? Platy, prismatic,
Granular, platy.
granular, blocky. Okay. So, in the soil which has with angular and heterogeneous structure is more stable for compaction. So, if you have all the particles, all the soil particles in prismatic nature, the prism will soon break down on application of compaction. The structure, the prismatic structure will easily break down if external pressure is applied, if a heavy machinery is passed, leading to collapse of the soil structure. Then compaction will happen. Similarly, if you have platy structure in the soil, you can very easily compact the soil, isn't it? All the plates are arranged one above the other. Then they will get jammed tightly. Okay, so heterogeneous structure is more stable for compaction. It will not get easily compacted. Similarly, water content. If there is excess water content in the soil, then the soil is highly susceptible to compaction, which we were discussing now. Because a water will form a shield over individual soil particles and reduce the particle-particle interaction. This particle-particle interaction is necessary to prevent soil compaction. Okay, that is why you are not supposed to plow the field when you have excess water or when the soil is too dry, isn't it? To plow the soil, you require an optimum moisture condition. It should not be too wet or it should not be too dry. Because of the an extremely wet soil will not withstand and the soil structure would be collapsed. You will have big clot formations. Everything will be done. Okay. Then bulk density. So when you have when the initial bulk density of the soil is higher, that is, if a soil is already a denser soil, then it will resist compaction to some extent because the particle-particle interaction is more. Okay, then organic matter content. So organic matter content. So far we have seen organic matter, addition of organic matter as a reclamation or a management strategy for all the problems so far, isn't it? All the physical constraints, add organic matter. Any chemical constraint, add